What's up, everybody? I'm Albie 13. Okay, so we're looking at today. I had I had Gemini help me build a virtual robot arm, and basically, we're doing a large language model AI, where I can talk to the AI, and the AI uses its tool calling to move the robot arm in virtual space. Here we can see the simulation, robot simulation that's going on. Um, let's I just tested this once. Now we're using the model Quen 3 8 billion parameter running locally on my PC at home. So potentially if someone wanted to use a larger model that works cloud-based, that could potentially give more performance. But the idea here is you could have a local robot arm and a local AI. 8 billion parameter, let's see what it can do. Now, the good thing about being in the beginning of 2024 is that Quen actually excels at tool calling, which is exactly what we really needed to do. So we expect it to do, let's say it's 94% performance on tool calling. It's essentially there for using it. Now, how this how this works is that the tool use has a X, Y, and Z. We can see moving arm to X point 3, Y 0, Z 0.5. So let's go ahead and say, I think it's going to only move the camera. So let's say, outstretch your arm to the side. Who knows? Whatever the interpretation of that order is. Okay. Went ahead and did that. It's actually sending it for inference over to the AI right now. So there's this lag while AI processes and then it completes. And we just saw the robot arm move. Okay. And actually that's about what you would have expected. I think that's a really beautiful demo. Now it says successfully called move arm. So we're seeing the tool calling being used well. Um if anything, I don't know, I'm just kind of thinking like what the AI is kind of reasoning and thinking. That's kind of curious, right? What else could I try, right? Let's say move the arm to the lowest position. Okay. Okay. And then move the arm to the highest position. I'd set Z to 1. Um, how about I'd say set Z to -1. Give it direction. It set Z to -1. Indeed, it did. And we do see that arm movement, but it doesn't really translate directly to. So we know that the AI is not really seeing what's going on. It's interpreting my command. Let's try reset position, see what reset position does. Okay, that's pretty cool. Interestingly, it doesn't give out um what are the coordinates for reset. Set the coordinates to reset by coordinates. So I'm kind of like operating the AI through commands a little bit more direct than usual. Just trying to get a feel for it. Set the arm to X0, Y0, and Z0.5. And this is supposedly some kind of apparently there is a reset position thing to call. Okay. So let's say move the arm backwards, whatever that might mean or entail. See what happens. Okay. Um, move the arm further. back. So I kind of can see the interpretation based on the X, Y, and Z. We'll be able to see that in a second. And it did pull it back, which is great that it's thinking about it, trying to do the command, and it is somewhat correct. We see, what are we seeing here? So we're moving the X coordinate -3, -5. So it thinks that it's pulling the arm back in position. So um, I would say that just simply based on our coordinates, it makes logical sense. We're actually not um, changing anything else. So theoretically, if you think about one axis, it's moving forward and backward. But what we're seeing in 3D space is how the arm moves. And that's why we have the bending and stuff like that. So I would say that this is a great success. And what I say is that, first you make it basically you can make it happen in virtual environment. And then if you had such an arm that this LLM AI could actually issue the tool calling to do the commands. And so we don't exactly have a huge amount of sophistication, but another thing that you could do is you could use the AI, not even necessarily with tool calling, but you could use the AI to select from predefined types of things. So this could be predefined positions and predefined movements. So if we think about the arm model, you could have a position where the hand has its hand out and up, and it's kind of like waving high, right? Or additionally, you can trigger an actual predetermined animation. Okay. So the hand could wave left and right gently. And all of that is happening in like an action model or an action system. And the LLM cerebrally thinks, I'm going to select what the arm is going to do. That's my job. My job is not to do micro, fine and could move the hand to the left by 0.1, move the hand to the right by negative 0.2, and then back and forth oscillate. This is something that we can think about. This is something that the AI can think about, but it can be a little messy. So these are just some of the information and ideas that I've been working on and developing last year and this year, end of the year last year, beginning of the year this year, obviously. I hope you found that interesting. Um, I think that this has a lot of potential and stuff. Um, I think that we have really great local AI models that bring a lot to the table, and we're going to continue to see even a little bit better AI models, which is truly amazing. And we just need the hardware to be available to the common people, so that we can have our computer systems to be able to do things. Finally, we get past the point of, okay, we have all the pieces to the puzzle. We can do all this stuff. What we're doing here is we're saying, no, we actually need it to do work. We actually need robots to help us do work. We actually need AI to help us do work. And this is productivity and making spreadsheets on the computer, right? And now we're kind of like shifting over this way and saying, well, we need this physical robot to do something at our house. We need this physical robot in our garage to do some kind of task. We need this physical robot to help us to do manufacturing as we have 3D printing and we have independent, um, we have developers, but of course we have builders and we have creatives and we have all kinds of things going on, enthusiasts. So we see that the enthusiasts are able to get their hands on this stuff, so to speak. All right, thanks for watching. Catch me on the next video. Out of here.